Greetings to all. In this video, we are going to deal with interpolation in numerical analysis. So let us consider a function y equal to f of x, whose values are ya plus h, etc. ya plus nh, corresponding to x is equal to a plus h, etc. a plus nh. Now, what is the meaning of the terminology interpolation? It is actually the process of finding the value of y that lies between two adjacent values of x. The same concept, if the x values are outside the range, then the finding the value of y is the process is what we called extrapolation. So this video, we will be dealing with the interpolation with equal intervals. We're going to discuss about the formulas for solving or finding the interpolation process. So two formulas are applicable for equal intervals. They are Newton-Gregory forward interpolation formula and Newton-Gregory backward interpolation formula. Moving on to Newton-Gregory forward interpolation formula. So the value of f of x for x is equal to x naught plus ph, and we'll consider this p any real number. And we can consider the function or formula e raised to p of f of x is f of x plus ph, where e represents the shift of the function from fx to f of x plus ph. So let us consider the function y as f of x naught plus ph according to our assumption for x. And that can be replaced by the above formula e raised to p f of x naught. And using the operator formulas, e can be represented as the shift operator, e can be denoted as 1 plus the forward shift operator delta, forward difference operator delta. So 1e can be replacing with the 1 plus delta, the whole raised to p into f of x naught. Now applying the binomial expansion for 1 plus delta, the whole raised to p, we get y of x is equal to 1 plus p delta plus p into p minus 1 by 2 factorial delta square plus p into p minus 1 into p minus 2 divided by 3 factorial into delta cube plus etc. times y naught. And multiplying y naught into the bracket, we get yx is equal to y naught plus p times delta y naught plus p into p minus 1 by 2 factorial delta square y naught plus etc. And this is what we call the Newton-Gregory forward interpolation formula. Then moving to the Newton-Gregory backward interpolation formula. The value of f of x for x is equal to xn plus ph, where p is any real number. We have e raised to p into f of x is equal to f of x plus ph. Also, use the formula E inverse is equal to 1 minus del. Del represents the backward difference operator. So, operating inverse on both sides, we get E is equal to 1 minus del, the whole raised to minus 1. And starting with the function y is equal to f of xn plus ph, replacing with e raised to p into f of xn using the formula mentioned above. And using the shift operator formula, we could write it as e can be replaced with 1 minus del, the whole raised to minus p into f of xn. And yx is equal to 1 plus p del plus p into p plus 1 by 2 factorial del square plus etc. into yn. And multiplying yn into the bracket, we get the Newton-Gregory backward interpolation formula. See, now where do we apply these formulas wisely in majority of the problems? Usually, we do prefer the Newton-Gregory forward interpolation formula for interpolating the values near the beginning of a set of tabulated values and extrapolating values of y a little backward of y naught. Whereas the Newton-Gregory backward interpolation formula is used for interpolating the values near the end of a set of tabulated values and extrapolating the value of y a little ahead of yn. So I guess you understood both the formulas, and we can wisely make use of these formulas to interpolate the values from a set of from a tabulated set. Thank you.